Alright, this next one here is going to use the idea that you got two tangent lines coming from the same point, so that should be 3 right there. This one is 4 and 4, so x is just going to be 3 plus 4, which is going to be 7. Not much going on there on that one. Alright, next one here, find the perimeter of this triangle right here, using the same idea here. If this is 13, this side's 13. If this side here is 8, this side here is 8. If this side here is 12, this side here is 12. And then we can go and add up all the sides. You could do it individually. I know the previous one there, I added up the sides before. You could just go 12 plus 12 plus 8 plus 8, and then plus 13 plus 13. That comes out to a perimeter of 66. But you just add up all of the sides. You can add them up as full sides or individual pieces there. There's 6 individual pieces there. So regardless, 66 centimeters there on that. You're just adding. Okay. Starting here from this section on, we're going to be using that formula chart quite a bit. You have a bunch of different angles. When the angles here that you're finding are outside of the circle, for these, you're going to do this big idea of big arc minus the small arc. And then you're going to do 1/2 of that, or divide it by 2. Okay, specifically 17, if you're looking for that one on your formula chart, 17 is dealing with an angle. 17 looks like this one here, where you got a tangent line and then a secant line. So let's see how that would be used here. So it was saying the big arc minus the small arc. It's going to be the 140 minus the 60, whatever that is, and then we'll do 1/2. So that should be 1/2 of 80, and 1/2 of 80 should be 40 degrees. 18, same idea. The issue is they didn't give you the small arc, so we're going to have to use a little bit of intuition to find it here. There's only 2 arcs with the circle, so you need to make sure to remember all arcs in a circle need to add up to 360. And if you've got one of them, you can go find the other by subtracting it from 360. That'll get you, I guess, 110 degrees right there for that arc. I'm going to write it on the inside. Typically we write them on the outside, but I don't really have much room to work with there. And then all we're going to do from here is do the big idea of the big arc minus the small arc. If you go and follow the formula chart, it is like this last one here, but that's saying the same thing. It's saying the big arc ABC minus the small arc AC, and that'll get us our answer. So that's 250 minus 110 for the formula, and then we'll do 1/2 of that. So I believe, what is that, 140, and then 1/2 of 140 should be 70 degrees. And that'll be it there. Okay. 19 is using a tangent and then a secant line, or I guess this is kind of a segment, but you get the idea. But it's pretty much the same exact formula, except it looks more like this. It is still the big arc AB minus the small arc CD, just whatever the big minus small is. So let's go ahead and do that. That's 85 minus 18, and then whatever that is, we'll do 1/2 of that there. That might come out as like a 0.5 decimal here. 85 minus 18, that's 1/2 of 67. And 67 divided by 2, or 1/2 of 67, is 33.5 degrees. And that'll be it there on that. Okay. Now 20 is not asking for an angle. It doesn't have any degrees. This one is asking for this piece of this chord right here. It's dealing with segment lengths. Anytime you're trying to find the length of a segment, or a lot of times, you're going to use these formulas down here. So this one's the one with the 2 chords crossing there in the middle. So all it says to do is do the products of these two here. So 2 times x, and then equals 3 times 4. And most of y'all will just write 3x equals 12, and that's fine. And then you divide, and then x is 6 here at the end.